What do you think aliens smell like?
For some reason, I think aliens will smell bad. I don't know if that's just an instinctive reaction, but I imagine them smelling like sulfur for some reason.
We are speaking with Dr. Lena Vincent today. She's an astrobiologist and a postdoctoral fellow at NASA's Jet Propulsion Laboratory. Recently, NASA formed its own team to investigate UFOs. So far, there's no strong evidence that these phenomena are extraterrestrial in nature, and a lot of these instances have been disproven. What can you tell us about these sightings? Do you have any theories?
Well, I think so far our lesson has been that these unidentified objects have an explanation. Now, whether that explanation is extraterrestrial in nature, at this point, we don't have any evidence to suggest that that's the case. I think basically many of them can be explained by the fact that we just don't know very much. There's still a lot we have to learn. And when we encounter things we're not used to seeing in our daily lives, it's easy for us to assume that they've come from elsewhere. So that's my grand theory about UFOs, is that we just don't know what we're looking at a lot of the time, and that can be very confusing.
Can you give us a couple of examples of these instances?
So I have a few favorite examples. One of my absolute favorites are what are called the Lubbock Lights that were observed over Lubbock, Texas in the 50s. There were this V formation of traveling lights. And it turns out, according to local ornithologists, that those are likely to be flocks of birds that fly in these V formations at night who have reflective belly feathers that basically reflect light back. Another really cool example are these really transient flashing lights that were seen above clouds by pilots. They really do look like UFOs, but turns out that they're actually a type of upward lightning. They're called transient luminous events. Some of them are called red sprites. I think a pretty widespread example are weather balloons. So these balloons that we're not used to seeing in our daily lives, that can look really weird and sinister, that fly far higher than we're used to seeing any balloon. And so there are multiple examples of UFO sightings that can be attributed to these weather balloons.
What is the most likely explanation to these countless sightings?
I think the simplest explanation is that in a lot of these cases, we're just seeing something we don't know or that we've never seen before. I think a lot of these cases demonstrate that things that were previously unknown can oftentimes have very mundane explanations that are still interesting, but don't implicate aliens or extraterrestrial beings in any way. To me, the biggest myth about UFOs is that UFO automatically means alien, right? But the first word in UFO is unknown. And unknown doesn't necessarily mean from beyond Earth. There is a possibility that these originate from beyond Earth. We can't rule it out. But in science, we rule things in based on evidence, not because we can't rule them out.
So could you tell us, in the search for, say, extraterrestrial life, what types of clues are we looking for?
So the main types of clues we're looking for are called biosignatures, which is a catch-all term for anything that is conclusive evidence of life, meaning that it can't be explained by some non-living explanation. Now, what exactly those biosignatures are is still somewhat of an open question, but in general, that's what we're looking for, are smoking guns for life that can't be explained via other explanations.
What is the strongest evidence that we currently have that extraterrestrial life might exist in other worlds?
Right now, our strongest evidence is a lack of evidence that it doesn't exist. So at this moment in time, we don't have any conclusive evidence that extraterrestrial life exists beyond Earth. But we don't know that it doesn't. And what we do know so far seems to suggest that it's unlikely that it doesn't exist. So no evidence, just absence of evidence that it doesn't exist.
Where in our solar system might we be most likely to find extraterrestrial life?
So that really depends on who you ask. I think every astrobiologist has their favorite candidate for a world in our solar system that might host life. Mars is a big one. I personally find the icy moons of the outer solar system, like Enceladus and Europa, to be particularly promising, just because we know they have things like massive subsurface oceans of liquid water. So that's where I would put my money personally.
I know you've done work looking at some of the distant moons in our solar system. Why might they be good candidates for potentially finding life?
So there are several reasons why I would bet money on some of the moons of the outer solar system being really good candidates for hosting their own biospheres. One is that they have big subsurface oceans. So below their icy shells, they have huge amounts of liquid water that are kept relatively warm. We also suspect that they might have other ingredients necessary for life based on some past missions. So one is we think that they have interactions between rocks and water, which turns out might be really important for the chemistry of life. Below the ice shell, there could also be some protection from radiation, which is really important in that outer solar system environment. So it seems like some of these icy moons may have several of the ingredients necessary to sustain life, which is why they're so promising.
Venus has been getting a lot of attention lately. We know that there are a couple of missions headed to Venus in the next couple of years. What do we hope to learn from these missions?
At this point, anything. Venus is such a mystery to us. We know so little about it, especially compared to our other neighbor, Mars. So anything we learn at this point is going to be hugely valuable. But in particular, some of the upcoming missions are going to be focusing on Venus's atmosphere and learning what that atmosphere is like as we descend into it. But anything we learn about its surface, about the conditions that exist there, and its atmosphere are going to be super revealing.
What can you tell us about the Venusian atmosphere?
It is not a fun place to be, at least for us humans. Now, it does depend on where in the atmosphere we are. So there are parts of it that are a little bit more pleasant. But as a rule of thumb, it tends to be very, very acidic. So hydrogen sulfide is one of the principal components, sulfuric acid. And so it would not be a fun place for us. It does rain acid there as well. So the little that we do know about the Venusian atmosphere suggests that it is a pretty harsh place.
And how does the Venusian atmosphere differ from the surface of Venus?
So the surface of Venus is really, really harsh. So pressure and temperature conditions there preclude any type of life as we know it. The atmosphere, however, depending on where we are in altitude, can be quite pleasant by comparison. So it can have temperature and pressure conditions that are more favorable. However, it is still very acidic.
Now, there are some researchers who have suggested that maybe we could potentially create cloud cities in the skies of Venus. Do you think that that's something we could potentially see in the future?
So I think that's a pretty ambitious plan and more in the realm of sci-fi at this point, but I do think that's a really cool idea. And it's inspired by the fact that some layers of Venus's atmosphere are more pleasant than others and could potentially sustain life. So I think it's a really neat idea. I think we are pretty far away from ever realizing that dream, but I think it's pretty cool to think about.
Several years ago, researchers announced that they had found potential biosignatures in the atmosphere of Venus. Those findings were later called into question. Why might Venus be an ideal place to find different types of life forms? Why might it be tricky to find evidence of life there?
So Venus and Earth are similar in some ways, but very, very different in a lot of critical ways, and particularly in the aspects that control whether or not we think they can sustain life. So finding life on Venus would be huge because it would suggest that life is possible in places that are very, very different from Earth. Now, the caveat with Venus is we think that deep in its past, it might have been more like Earth than it is today, meaning that it might have had oceans, much more pleasant temperatures, a breathable atmosphere. Now, that is not the case anymore. But finding life there would be really interesting, or finding evidence of past life, even if it's long dead, would be very interesting and very critical for astrobiologists to better understand the limits of life in our solar system.
On Earth, we know life is carbon-based. How might the chemical composition of life differ in other parts of the universe?
So there are some ideas about alternative chemistries of life that are not based on carbon. So one really popular one is silicon, because silicon and carbon are periodic table neighbors and they are quite similar in some ways, but they are also very, very different. And so a silicon-based life would be radically different from what we're used to here on Earth. In other places beyond Earth, one thing we might look at is what elements are abundant there. So what is there around to make a chemistry of life with? And that is an open question. We don't actually know for sure what's possible elsewhere based on what's available. But it does seem plausible to imagine that there could be chemistries of life that are based on something else, or hybrid chemistries that are based in carbon, but also something else like silicon.
What types of environments do scientists study here on Earth to learn a little bit about what life might look like in other worlds?
So there are lots of potential places to look. I think astrobiologists tend to gravitate towards really extreme environments. And that can range from really dry environments like the Atacama Desert, but also really cold places, places that might mirror what we find in the outer solar system, or even Mars, which is really, really cold and dry. And one really, really exciting location is Antarctica, also the Arctic. So in general, really extreme places where conditions are really harsh tend to draw our attention as scientists because we think that they have conditions representative of these other worlds.
Do Earth's oceans give us clues about what life might look like elsewhere?
So Earth's oceans are undoubtedly a really interesting place, especially the deep ocean, the deep biosphere. We find organisms there that just kind of defy our expectations of what life should look like. So maybe there is a lesson there that life can take on these really strange, interesting forms.
What about geologically active areas like, say, geothermal vents beneath the ocean? We know that there's a lot of microbial life down there. We find extremophiles. What can we learn from those regions?
So those are by far some of the most interesting places on Earth. And one really cool thing is that the biosphere that they support is far more diverse than we ever could imagine. And interestingly, we also think that these kinds of environments might have been important for the origin of life itself. And it's really interesting to think about whether similar systems exist on other worlds and whether they might host an origin of life.
So could you tell us a little bit about how we think life might have originated on Earth? How do we think life evolved on this planet?
That is a huge mystery, and we really don't know very much. It's very hard to study. Obviously, we can't go back in time and watch it unfold in real time, but we do have a pretty good ideas. So we do know that at some point, chemicals that were not living assembled into the first living things. We think that certain environments, like hydrothermal vents, might have facilitated these kinds of reactions, but that's the extent of what we know. All we know for sure is that it happened, and a big community of scientists dedicated to studying this question are working really hard to make progress.
We often hear the phrase, the building blocks of life. Could you tell us a little bit about what exactly these building blocks are? What do they consist of?
So the building blocks of life are basically the essential molecules that make up all cells. So things like proteins, nucleic acids like DNA, sugars or carbohydrates, and lipids. Now, these can be found across the tree of life in every single type of cell you can think of. And so that's why we refer to them as these building blocks of life.
There are several theories about how these building blocks, how these molecules, these sugars, these, say amino acids, how they originated here on Earth. There are theories that suggest that an asteroid might have carried them to our planet. Could you tell us a little bit about what some of the working theories are right now?
Yeah, so I think this idea of panspermia, of these building blocks or life itself being transferred from beyond Earth to early Earth through things like asteroid impacts, is super interesting. Unfortunately, right now, we don't have the tools in science to figure out whether that actually happened. But I think there's good evidence to suggest that asteroid impacts played some role in delivering at least part of the building blocks needed for life to get started. And that's because we know these space rocks, some of them tend to be rich in the building blocks of life, and we know that there was a time in Earth's history where these impacts were happening really frequently. So I think it's a really elegant idea to think that our origin might in part be explained beyond Earth.
I have another big question for you. When do you think life on Earth might end?
I can imagine it ending in a few ways. One thing we know for certain is, millions of years in the future, the sun, because of its natural evolution as a star, will eventually engulf the Earth and will make life impossible here. So I think it's safe to say that at that point, life on Earth will end. There are also other threats, pandemics, illness, effects of climate change, but it's really hard to predict which of those will ultimately mean that life has met its end.
Curious about UFOs, interested in aliens? Do you have a passion for astrobiology? Check out our website to learn more about all of those topics and more.